Hey students, now that you've learned how to create truth tables to test sentences and sets of sentences, we're going to use it to test arguments. So this is how to create a truth table to test for invalidity. So you're going to get out a pen and paper again. You're going to set up the truth table the same way as you do for comparing propositions, except you're going to put a double slash to indicate the conclusion and a single slash to separate premises. The law of identity still applies, so make sure that the values stay constant throughout the truth table. So if you assign a value to a variable on a row, wherever that variable pops up later, you're going to assign the same value on that row. Now, we classify it by checking for invalidity. I've mentioned this before, I think, but we can't test for validity because validity comes in so many different forms. Instead, we test for invalidity, and if it's not invalid, then it is valid. So to check for invalidity, what we're looking for is we are looking for this right here, this pattern where the premises are all true and the conclusion is false. If there is at least one row on your truth table where the premises are all true, consistent, and the conclusion is false, then that argument is invalid. You don't have to keep checking the truth table. As soon as you find one row wherein they're invalid, the whole argument is invalid. If you don't find an invalid row on the first row, the second row, the third row, go all the way down to the very bottom row. You must check every row to make sure that it doesn't turn out to be invalid on one of those rows. So here I'm going to do this one with you. So we've got negation A, so false, false, true, true. And we've got negation B, so false, true, false, true. And then we got A, then B. So true then true is true. True then false is false. False then true is true. And false then false is true as well. Now we're going to go line for line. So on line 1, premise 1 is true, but premise 2 is false. So it's not invalid on line 1. On line 2, both premises are false, so it's not invalid on line 2. On the third line, we got 2 premises that are true and a conclusion that's false. So therefore, this argument is invalid. Okay, remember, you're not done, just like when you're testing statements for their logical, if they're logically equivalent, for example, you want to write your answer out as well as fill your truth table in. Okay. So here's the next one. This is G, C, if and only if G, negation G or C, and then G implies C. So we're going to fill this in. Here we go. So true if and only if true is true. True if and only if false is false. False if and only if true is false. And false if and only if false is true. Now we're going to do the negation for this or. So false or true is true. True or true is true. False or false is false. And true or false is true. Last one is our conclusion. So true then true is true. False then true is true. True then false is false. And false then true is true. So line 1, we have 2 true premises, but a true conclusion, so not invalid there. Line 2, we have 2 false and a true premise, so not invalid there. Line 3, we have a false and a false premise, as well as a false conclusion, so not invalid there. Last line, they're all true. So this one is not invalid, therefore it is valid. So I want you to do these on your own. Create the truth tables and state whether these are valid or invalid. Z or not H. Z, conclusion, not H. A implies B, B implies A. Conclusion, A if and only if B. So pause here, give yourself time, do this work. If you haven't yet, take out that pen and paper. Logic is like push-ups. You must do the work to build the skill, not just watch the work get done. So here I go. I'm filling in these values for you so you can check your work. So negation H goes false, true, false, true. And negation H here goes false, true, false, true. So this or here goes true or false is true, true or true is true, false or false is false, and false or true is true. So now we're going to compare for the main value. So true here, and false here. So we have a line wherein we have true premises and a false conclusion. Therefore, this argument is invalid. We don't need to check the rest because we found a line wherein it's invalid. Therefore, it is for the whole invalid. Next, we're going to do this one. So here we go. True, then true is true. True, then false is false. False, then true is true. And false, then false is true as well. So here we go. True, then true. False, then true is true. True, then false is false. And false, then false is true. A, if and only if B works like this. So if they're both the same value, so here, true, if and only, this should say false here, sorry. That's weird. My B is all incorrect here. So this should say A if and only if B, true if and only if true, true if and only if false. This should say false if and only if true, which is also false, and false if and only if false, which is true. Sorry about that typo. And here we go. So true, true, true. So not invalid there. False, true, false. So not invalid there. True, false, false. So not invalid there. And true, true, true. So not invalid there. Therefore, this argument is valid. Okay. So 2 more arguments for you to do. You might want to pause it, write these out, and then you're going to fill these in. So first this version. We're going to pause for a second. I'm going to fill this in. Okay, so we're going to do the second one first. It's a little easier. So here we go. So I filled in all the values and I want you to compare it to your own truth table. Again, you have to do this work. You can't just watch me do it. And now we're going to look across. So the first line, we got I've got a true premise and a false premise and then a true conclusion. Second line, I've got false, true, true. So I still don't have true, true, false. Third line, I have true, true, and false. Here we have a line wherein it's invalid, therefore this argument is invalid. Now we're going to switch to the second one. Second one, here are the completed. This time I have them highlighted on the main operator so that we can check. To make it easier for us, once we have this many rows, I'd like to just check where the row can have false in the conclusion. So if I look only at those rows, I'm looking to see if we have all true premises here, and we do not. False conclusion here, all true premises, no. False conclusion here on line 6, all true premises, no. And finally, false conclusion on line 7, all true premises, no. So this argument is valid. Okay, last one I want you guys to do. this is, sorry, I didn't realize I had it like that. This one, I want you to symbolize first, and then you're going to create truth tables and state whether they're valid or invalid. So the first one is the cat jumps, then the cow goes moo, but the cow didn't moo, therefore the cat didn't jump. Number two, you drive neither a gas-powered nor electric vehicle. When you drive an electric vehicle, you pollute. When you drive gas-powered vehicles, you pollute, therefore you pollute. So symbolize these. Then when you're ready, go on with the lesson. And here we are. So I'm going to do this one with you. For this is the cow and the cat, okay? So we've got true then true is true, true then false is false, false then true is true, and false then false is true as well. Negation of true is false, negation of false is true. That pattern repeats. And finally, the negation of true is false, repeats, and negation of true false is true, repeats. So we're going to go over and we're going to see if this is a valid or invalid argument. Line 1 has a false conclusion, but the premises are not both true. Line 2 has a false conclusion, but the premises are not true, both true. Line 3 and 4 have true conclusions, so there's no way that this can have this pattern. Again, we're looking for true, true, false. We do not find that. Therefore, this argument is valid. And the last one for you guys to do, if you filled this in, these are the values that you'll have on each line. If you filled them in the order that I filled them in, if you filled them in a different order, you might still find the same answer, but you'll find them in a different pattern. So again, I'm just going to focus right here on trying to look when this is false. So these are not all true. They're actually all false there. Then we have false again right here, but they're not all true. False here, but they're not all true. And then finally false, and they are all true. So therefore, this argument is invalid. There we go. So that's what you have learned this week, and we're going to continue on with learning about indirect methods. So a method that is based on this method is what we will be learning next. So this was your learning objective for this module. Use truth tables to determine whether arguments are valid or invalid.